Today we're going to start talking about our next unit, which is called law of exponents. So make sure you have a piece of paper so you can write these notes down. So the next topic is law of exponents, and that's exactly what it says. I know what an exponent is, right? Like if I have 4 to the third power, I know that's the same thing as saying 4 times 4 times 4. That is 64. Right? Or I could have just typed this into Desmos 4 to the third power, and I would have also immediately gotten 64. That's what an exponent does. So we have a few laws that deal with exponents when problems get trickier. So if I just again review, if I have 3 to the 6th power, that's equivalent to saying 3 times 3 times 3 times 3 times 3 times 3. And if I were to type all of that into my calculator, or if I were to just type that into my calculator, I would end up getting 729. Because what an exponent tells you is it takes the base, which is the big number, and it multiplies it by itself the number of times the exponent tells me. So my big number is called the base, my little number is called the exponent. So we might actually want to write that down. So I'm going to just do letters like that, x to the a. This is called my base. And this is called my exponent. Okay. So when exponents get a little trickier, when I have more complicated problems, which is why I have laws to follow. I have rules, just like PEMDAS or GEMDAS. I have to follow those rules in order to simplify a numerical expression. I have a bunch of rules, laws, that deal with exponents. There are a total of 6 laws. We're going to learn the first 3 today. So the first one we're going to learn is one of everybody's favorite, and it's like the common sense, we already know this, it's 1 as an exponent. So this is the first rule. So what this rule tells me, if I have a to the first power, because 1 is an exponent, that's just the same thing as a. So if ever a number doesn't have a variable, if any base doesn't have an exponent, its exponent is assumed to be 1. There's an invisible 1 right there. So that's what 1 as an exponent says. So if we write that down so we have it, any base without an exponent is 1. So any base without an exponent is 1, meaning the exponent is 1. Okay? So if I have 2 to the first power, that's the same thing as 2. If I have 3, 3's exponent is an invisible 1. Okay? So that's what the first rule tells me. The second rule, 0 as an exponent. This one really is everybody's favorite because if I have a letter or a number, and we'll call it base A, and I raise it to the 0 power, that always equals 1. So anything to the 0 power is 1. So if I have 3 to the 0 power, that equals 1. If I have y to the 0 power, that equals 1. If I have 12 times x all raised to the 0 power, that equals 1. If I have smiley face to the 0 power, guess what that's going to equal? 1. That makes sense? So now I want you to try this problem. 2x to the 0 power plus y to the 0 power. So this is where you have to use some brain power here. I know this 0 power right here. Is it going to x, is it going to 2, or is it going to both? Well, it's only going to x because I don't have parentheses. So x to the 0 power, that equals 1. So now I have 2 times 1 plus y to the 0 power equals 1. So now 2 times 1 is 2, and 2 plus 1 is 3. All right, so now you try this one. 2x to the 0 power plus 3y to the 0 power. Try this one. Maybe pause it and see if you can figure it out before I explain it. So hopefully you got 4. Because all of this is being raised to the 0 power, so all of this equals 1. And then y is being raised to the 0 power, so that equals 1. So now that's plus 3 times 1. And 3 times 1 is 3, and 3 plus 1 is 4. Okay? So we've just learned 2 out of the 6 laws of exponents. So now we're going to talk about the next law. The next law is when I have negative exponents. Negative exponents we've never seen before. We've seen positive exponents. We have seen 0 as an exponent like we just did up there. We have never seen a negative exponent. So if I show you a to the negative n, okay, whenever you have a negative exponent, that's going to turn this into a fraction. So I can turn any number out there into a fraction by putting a what under it? Well, I can put a 1 under it, okay? And every time I have a negative exponent, I'm going to circle it, and it moves to the opposite side of the fraction. So notice I turn that problem into a fraction, and if that's on the top, the only place it can go is the bottom. So that's going to move to the bottom, and when it moves to the bottom, my negative exponent magically turns positive, okay? Because that's what negative exponents mean. Negative exponents mean there's going to be a fraction. Now notice there's now nothing left on the top, so when the only number out there that's invisible and nothing's there is 1, okay? So a negative exponent makes a fraction. So negative exponents turn a problem into a fraction. Now, if I already had a fraction, I wouldn't have to turn it into a fraction because there's already there. I'm not going to put a fraction inside a fraction inside a fraction. I'm just going to move it. If my negative exponent's on the top, it's going to move to the bottom. And if my negative exponent's on the bottom, it's going to move to the top. So if I look at an example, and I see x to the negative 2, I know I'm not allowed to have negative exponents. It's illegal to have negative exponents. So I want to turn this into a fraction. How do I turn this into a fraction? By putting a 1 under it. I circle all the bases that have negative exponents. So in this case, x has a negative exponent. And because it's on the top, I'm going to move it down. So x squared goes on the bottom. And remember, when I move my negative exponent down, it becomes positive. Nothing's left on the top, so it gets a 1 on the top. Okay? So let's go ahead and let's look at a couple of problems. If I had x to the third and y to the negative second, okay? Again, your directions on these would be the exact same as our radicals unit, which is where we just simplified. All we're doing is simplifying. So I see I have a negative exponent. I'm going to make this a fraction by putting a 1 under it. I'm now going to circle all the bases that have negative exponents. So what bases have negative exponents? X, y, or both? Well, y has a negative exponent, so I'm going to move him down. So I'm going to move y squared down, and when it moves to the bottom, it turns positive. And I no longer need that 1, I hope you notice, because 1 times anything is just itself, so that's why I just kind of ignore it 1 time there. Now notice x cubed didn't have a negative exponent, so am I going to move him? Nope, he's going to stay right on top. And I'm finished. Let's go ahead and if we had a number. This is the number 1 misconception. 4 to the negative second power. Everybody sees that and they go, oh, I know 4 squared is 16. So 4 to the negative squared must mean negative 16. But that's not true. Because what do negative exponents do? Negative exponents turn something into a fraction. So if I put this over 1, and I circle my base that's negative, which is 4, has a negative exponent, and I move it to the bottom, 4 squared comes positive down here, and then I have a 1. And if I simplify that a little further, I'm going to have 1 over 16. Is 1 over 16 the same thing as negative 16? No. So So that's when you really have to be careful when you have negative exponents. That does not mean the number itself becomes negative. That means it turns it into a fraction. So we're going to go ahead and we're going to practice some problems. You're going to combine all three rules you've just learned. After this notes, you've learned half of your laws. There's a total of 6 laws. You've just learned 3. Anything that doesn't have an exponent is assumed to be 1. If I have a number raised to the 0 power, it equals 1. And negative exponents turn something into a fraction. So my directions are just going to say simplify. Okay? So if I have 3x to the 0 y. So if I look at this problem, the first thing that I notice that's a red flag for me is x to the 0. Notice x is being raised to the 0 power, 3 is not being raised to the 0 power, and y is not being raised to the 0 power because they're not in parentheses. And 3's exponent is 1, and y's exponent is 1 because there's nothing there. But I know x to the 0 power equals 1. So 3y times 1, well, that's just 3y. And I'm done. If I look at another one, if I have 4y x to the negative 3. All right, so what's alarming in this problem? My directions are to simplify. My directions are to make this look cleaner. What's alarming? Well, negative exponent. So what has a negative exponent? 4y, x, or everything. Just x. So I'm going to circle x. So what do negative exponents do? Well, they turn things into a fraction. So I'm going to put this over 1. And because it turns it into a fraction, x is really going where? To the bottom. So I'm going to rewrite this, and I'm going to put x cubed on the bottom. What about 4 and y? Do 4 and y go to the bottom, or do they stay on the top? Well, they're going to stay on the top because they didn't have a negative exponent, and I leave it as is. What if I had this? What if I had 5x over z to the negative 2? So when you're simplifying, you always want to look for the things that are alarming. What do you notice that's alarming? Well, I see a negative exponent. So what do negative exponents do? They move on the fraction. So notice this is already a fraction, so I don't need to make one. But since z is on the bottom and it's negative, where does z really belong? Z really belongs on the top. So I'm going to rewrite this and keep 5 and x on the top. And I'm going to move z squared to the top. Is anybody left on the bottom? No. So I would just put a 1 there. Do I really need that 1 there? No. So I'm just going to circle my answer. What if I had this? What if I had 3x to the negative 2, y squared z, all to the 0 power? If you notice this problem, what's alarming? Well, I have a negative exponent and I have an exponent of 0. So I work from the outside in. So look what's on the furthest the outside. This is 0 exponent. Now, does that 0 exponent belong to everybody or just one piece of this problem? It belongs to everybody because it's in parentheses. So everything raised to the 0 power equals 1. And I'm done. Okay? Let's practice a few more different types of examples. I want you to try this one. 7s to the negative 4 t squared all over w to the 0. So I want you to pause this video, and I want you to try this one on your own, and then I want you to unpause it, and we'll go over it. So the first thing I notice is alarming, and that's the easiest, is w to the 0. That just makes 1. I now see I have a negative exponent, so I circle it so it helps my brain. So where does s go? S is moving to the bottom. So 7 and t squared stay on the top, and s to the 4th go to the bottom. You know you're done and you can circle a problem because you have no negative exponents and each of your letters only show up once. I see t once, I see 7 once. If I saw multiple 7s and multiple t's, then I know I would not be done. Okay? So now try this one. If it'll let me hit the undo button. Z to the negative 3 all over w to the negative So same thing, pause this video, and I want you to try this one on your own. So I see y to the 0, so I just cross it out. It makes 1 because anything times 1 is itself, so I know I can just get rid of it. I now see z is negative and w has a negative exponent. So that means z is going to the bottom and w is going to the top. So the guys I didn't touch are 3x squared. Z cubed goes to the bottom. W squared goes to the top. I know I'm done because every letter is only seen once. I don't have like x, x, x over y, y, y. I only see x once and w once and z once. And I have no negative exponents. What about this one? So with this one, if you want to pause it and try it first, 4 to the negative second goes down. T to the negative 3 goes up. So they're really just switching places. This is t cubed over 4 squared. If I circle that, I'm losing half a point because I can still simplify 4 squared. So 4 squared is 16. So whenever you have a number with an exponent, when your base is a number, you can just go ahead and simplify. And I have one last one I want to talk about today. What if I had this? Negative 4x to the negative 2. So what I notice is alarming is I have a negative exponent. So what has a negative exponent? 4x or both? Just x. A lot of people like to say 4 has a negative exponent, but it doesn't because 4 is just negative. Its exponent is still just 1. So the only person I'm moving to the bottom of this fraction is x. So negative 4 is going to stay on top, and x squared is going to go to the bottom. Okay? So you've just learned the first 3 out of the 6 laws of exponents. If you have questions, come and see me.